Hello and welcome back to Slapping Together Songs, where we try to make unique music because it's slightly less pointless than making generic music. Today we're going to be making some random walks for Slundge. Now, what is a random walk, you might ask? It is a sequence where at each step, the direction you take is chosen randomly. So random walks can be used to model things like the motion of molecules in a fluid, so how things diffuse. Oh my fucking god, the cloud, it just fucked me over again. So what we're going to do is make some notes follow a random walk. So we'll take like maybe 4 notes. So these 4 notes will start at the same note, and then they will kind of diverge over time, wiggling around sort of randomly because the probability of them going either up a semitone or down a semitone at each step is the same. We're going to fire up a Jupyter notebook. All right, so we'll open up this. We'll go over here, create a new Python 3 notebook. So let's see, we'll import numpy as np, import pandas as pd. I guess we'll import matplotlib pyplot as plt, kind of your typical numerical Python boilerplate. So let's just start off with what we know. We'll say 4. No, you know what, let's do 5 notes. So we'll say n equals 5. Say our data frame equals data frame. No, you know, we'll just start off with let's make a function that will create a numpy array of a random walk. So let's say def make walk, and then we'll say length. We'll do, yeah, length equal, how many notes do we want to put in this? We'll say maybe 50, I guess, as the default for now. So now we just got to create an array of steps. So we can do a equals np.random dot. Let's see. So let's pick. We can do either. It doesn't really matter which distribution we use, I guess. See the docstring by pressing Shift Tab. So this is random numbers of a given shape. So this will be a uniform distribution in the interval 0 to 1, closed on the left side. So what we will do, we'll just have this, we'll give it the length. So we'll just have a bunch of random numbers. Let's actually show this right now. Make walk. Oh, we need to have this return that value. So let's make the walk, and you'll see we have a bunch of random floats between 0 and 1. And what we can decide here is that if we are greater than or equal to 0.5, it's going to be a positive step. We're going to go up a semitone, so it'll be +1. And if it's below 0.5, it'll be negative. So we'll say a greater than or equal to 0.5 equals 1, and then a, where a is less than 0.5, equals -1. And we'll return a, and actually we can just like plot this really crudely. So we're getting there. This isn't a random walk because it needs to be, these are the steps. This isn't the position. So you can see you're doing a positive step or you're doing a negative step. So maybe we should put a start value in here of 0, and we'll do, let's call this steps. Well, let's call it S for steps. And we're going to make a new array called walk, which is basically just going to be the cumulative sum of the steps. Actually, we can just go np.cumSum of S. This is our walk and our starting value. So now, oh, there we go. We have our random walk. So we see how it diffuses outwards. And we can make this a couple times and see how it can go in different directions. And you have different shapes every time. So we're going to make this walk. The only problem is that if you do using the cumulative sum, it's going to start on either -1 or 1. So maybe we just need to make the first step 0. So we always start from the start value. Now, it always seems like we go positive at the very end. Like we always diffuse upwards, or I haven't, it doesn't look like I've seen one go end on a largely negative number. It's kind of interesting though that sometimes you'll have these large sections where you're going negative for a few steps in a row. So random shapes coming from, let's see what happens if we use a normal distribution using rand n. Huh. It always goes negative when you use a random distribution. It's possible that this is distributed between two different values rather than 0 and has a distribution of mean 0 and a variance of 1. So in this case we would do if it's greater than 0. Actually, that would be kind of interesting. We'll say if it's greater than 0, it'll be 1. If it's less than 0, it'll be negative 1. If it's exactly 0, we'll make it 0. So you have the possibility of staying on a given note. Let's see how that looks. Yeah, so it's about the same. I mean, you can have the walks can go positive, the walks can go negative, since it's normally distributed about 0. It's probably less efficient to do it this way, using a normal distribution, but who really cares? Actually, let's see if Brownian Motion follows a Gaussian. Let's take a look at the Brownian Motion Wikipedia page. Random motion in a fluid. So the reason why I want to embed some fluid dynamical concepts into the songs because it has some lyrical themes related to fluid mechanics, or more generally continuum mechanics, and how they relate to society. Like, you know, maybe that's you. You're one of these little colliding molecules tracing out this nearly random path. But it's really the bulk movement of this, let's say, a liquid in the ocean. The bulk movement is what makes the impact. It's these little random motions that are happening inside of a wave, for example, crashing on a beach. Those motions really don't do that much. So, yeah. Well, let's see, what's the distribution? I guess it can be, they look Gaussian, they look bell-shaped curve, they're calling them. These, of course, are 3 dimensions. We're only looking at 1 dimension. It always moves forward 1 step in our song. Oh, this is a bigger particle moving through. I wonder if we could relate that to music somehow. You know, a bigger musical structure could be a chord. So you could maybe have a chord that goes on a random walk, and its position is governed by, you know, colliding into these notes over time. You know, if it hits this, maybe it bounces off, and the entire chord could move. But for now, we're going to just build this as a chord. 1 chord made of random walkers. So yeah, we got a function that makes random walks. We can make the length, let's make the length 100 steps long. Let's make it 1,000. Let's see how crazy it can diverge. So yeah, you can see if you had to do 1,000 steps, you could diverge out to 60 over time. All right, so we have a function to do this. Basically, this will be semitones at this point on the y-axis, which is not quite where we want to be yet, but that's fine. Actually, I wonder if there's a convenient function. I wonder if it's built into something already. Like, I mean, this is pretty simple here. So this guy's doing, oh, that's kind of cool. That the time evolution of the mean square distance. Okay, so this plot is not the actual position. How many steps did these guys do it? 1,000. So yeah, we're doing it 1,000. I don't know, these guys are doing 1,000 different walkers with 200 steps each. Oh, these guys are doing a 2-dimensional array to start with, which maybe maybe would be smart to do. Instead of trying to use a pandas data frame, we can just use the 2D array. How did I miss that? Yeah, might as well do it this way. Use random integer. That way I don't have to convert them. This is part of programming, just taking stuff that you find on the internet. And all right, so there we go. We got our bunch of random walks. Let's make them huge. Let's make really long random walks. See, they diffuse. We're obviously not going to be going this many steps. Let's go even more. Whoa, dude. Interestingly, they get closer. These all get closer over here. And this green one's way off on his own, and then randomly starts coming back when these all start diverging from each other. But, yeah, I guess that's why it's called random. All right. We have code to make walks. Now, we need to figure out some way of making this into MIDI files. Spacebar sucks. So, let's see what's out there. I've never done anything with MIDI in Python. So let's see. What's the best package out there? Oh, you know what? I have done stuff in MIDI with Python. Let's see how easy this is to build a MIDI file from scratch. A pattern, put a track in it. And this is a little bit more control than I really want here. PyMidi. Oh, this is for sending and receiving MIDI messages, so if we ever wanted to send this out to a device to do this live, maybe a keyboard or something. It's not what we're looking to do right now. MIDI objects for Python. MIDO. We want to work with MIDI files. MIDI util. This guy allows you to create MIDI files. Let's see the quick start. So that's good. We can start with integers. Track channel, yada yada yada. That's easy. BPM. I don't think we really want to. I guess we'll put in the tempo that matches with Slundge. Song we're working on here. I don't know where I'm gonna put these random walks, but basically just gonna drag them into the project. So over here, the tempo is 174 divided in eighth notes. Well, this looks like a good package to use. So let's just pip install MIDI util. Pip install MIDI util. Well, it looks like I already installed it at some point. Okay, so we'll just copy and paste this code here. And we'll fix it up to do what we want it to do. Press B in the notebook to create a cell below. Let's put our tempo as, what did we say it was? 174. Changes throughout the song. And I believe we can just import this without any of the tempo information. We'll just get the, so duration 1 beat, that makes sense. Time, I don't know what that means. What does time mean in this context? I wonder if you can play the MIDI files. Oh, Jupyter should be able to do this. We want to be able to play these files in the notebook so we can hear what it sounds like. Oh, that's interesting. There's a Music 2.1 toolkit developed at MIT for computational musicology and generative composition. That's kind of what we're doing right now. I wonder if it'd be funny if they actually have random walk generators in here. Huh. Definitely have to check this out again at some point. Play MIDI. Pygame.midi. Okay, so I don't like the programming style of this block, but We're going to write this. Just make sure that works. Okay. Make sure that that's there. Major scale.midi. All right. We'll need to find some way to play this. Music 2.1. That's what we were just looking at. We're going to install that. Music 2.1. I don't know if it's supposed to be called Music 21 or what. Let's hope it doesn't require any sort of compilation. Music 2.1 play MIDI file notebook. Let's see if we can figure out how to do this. Why is this such a huge package? 18.4 megabytes of source? Maybe it has a lot of files included with it. Wow, this is taking a long ass time. Oh wow. Music 2.1 has some good stuff in it. Music 2.1 GitHub. Let's see if it's on GitHub. Wow, this thing is destroying my computer right now to try to build this. Cuthbert Lab. These guys are right down the street from me. Alright, I'm going to stop streaming, stop recording for a second. Alright, so Music 2.1 just installed. This is good. Now we need to copy and paste this, unfortunately. This guy put a bunch of screenshots instead of text. So, from Music 2.1, import MIDI. Actually, let's just put the imports up here. And what do we got to do? I found this other package called Pycnon for generating MIDI, which I guess, could probably use that in lieu of this MIDI util. It might actually be easier. You still have to create these notes. Okay, so we got to open this file name. Define this as a variable. We open the file, read it, and put it into midi.translate.midi. Man, I hate not being able to copy and paste. I should probably put this in a different window. So we're doing midi.translate MIDI file to stream with all the contents of the file. Oh, this is translate MIDI. Oh, looks like we can just do a MIDI file path to a stream. Just do fname so we don't have to actually open this file and read it. And then we just do s.show. Let's see if... Oh, why does this open in the default? Play MIDI. Here we go. Guess I typed the wrong thing here. I don't know what time means. Oh, time is the length of the MIDI file. In seconds. Oh no, it's the total length of the MIDI file. Okay, I gotcha. I'm just gonna call this MF. So we're adding notes at time. Oh, this is the start time. Okay, this is our initialization of time. So we have 8 notes, so we're making this 8 beats long. What if we made this 4 beats long? This duration doesn't make much sense. Oh, that was the duration of each note. In time, we're only going forward 1 beat in time each time we enumerate this. I actually don't know what the MIDI note numbers are. So we want to actually start this at the MIDI note number for A flat flat MIDI note number, or G sharp, I guess. So these ones are starting on 60. MIDI note number 60. Guessing it's a C. Okay, it's middle C. That makes sense. So what's the nearest A flat or G sharp? 56. We'll start on 56. And then we'll do, let's just make a new cell here. This is just our making a major scale. Copy and paste this cell below. So yeah, actually this is interesting. I don't know if I want to do one random walk at a time in a file or do all of them in one file. Probably all of them in one file and put them all into one instrument. So yeah, let's do that. And that will say for our degrees, we're going to say equals make walk. Let's do it 10 long for now. And we'll do 5 of them. So we're going to have to do, we're going to iterate through the degrees, but every time we do this, we're going to have to add multiple notes. For this will be like a pitches. So at each, for each row in our array that we created, we have a bunch of pitches, and we need to then get the pitch for each one of our walkers. So let's do for pitch in pitches, then we add more notes. Oh, we need to do make walk, and we need to start on 56. Start 56, since that's like kind of our key. That's kind of cool. That's a random walk. And then if we run this again, we'll get another one. Now we should try to give these unique names by maybe if we can hash the degrees or something like that. That way we have a unique, actually we should probably, one thing we need to do in this function is allow for putting in a random seed. So this function, oh, can we not put a seed into this? Rand int seed Python numpy. Okay, so we'll say seed is none by default. Then we'll seed the generator, so it allows us to get reproducible results. So let's just try this again. With a seed, seed equals 5. We'll get the same one every time. If we do seed equals none, we'll then get a different one. All right, let's see. Creating hashes in Python. This is for dictionaries. We want to get a unique identifier for an object. Let's see if we can hash this. Hash degrees. It's not hashable. To list. Can we make this into a list? I guess it doesn't have a toList method. Let's try to make degrees into a list. List is not hashable. What about tuple? Hash numpy array. Let's turn it into a string and hash it. Okay. So that's cool. We'll have like a unique identifier for whenever we create one of these, so we can kind of name it in a way. So let's just create the hash string of degrees. So if we create many of these, we'll be able to pull them back up. We'll end up with a directory of these. So let's ls here. Let's make this 20 notes long. So you can see we just created, oops, I'm supposed to use a F string, not R there. rm random walk. Got rid of that weird file. So let's see. We just created a unique one. Let's play it. 20 notes long. This is with a seed of none. Let's put in a seed of 6. So it's kind of interesting, actually. You could make a pattern with like seeds or something. And then it kind of goes through this process of making you these random walks that are kind of deterministic. You could recreate them because you know the pattern of seeds. Like imagine, take a melody that you know, like Mary Had a Little Lamb. You could have that as a sequence of seeds that go into the random number generator. Have them follow random walks. And of course, you could have the random walks actually pick notes out of a scale instead of picking, you know, right now we're doing this totally chromatically. But that would probably sound pretty cool if you had this go out of, you know, moved up and down the scale according to the steps. But right now we're going to do this completely randomly. So let's see what MIDI files we have. ls. So I mean, we can just keep doing this a bunch of times. Maybe we want to actually notate what the seed was in the file name. So seed equals none. We'll put seed equals seed. So we'll do if seed is none, we'll call the file this, else fname equals. We'll just put an identifier in here actually, instead of having any copy and paste. So we'll do identifier equals the hash of string of degrees, else ident equals, and we'll just plug that into the MIDI file name. So we know each time, so seed was none. Let's see what file we got. We got a random one. Maybe I should name them based on how long they are too. These are our input parameters. Ident, and we'll just add to the identifier with the length. So we have random walks, length 20. Then we have our kind of unique identifier. And what if we do a seed? Seed is 6. We get a file, random walks, length 20, seed is 6. So that's a way of uniquely picking out which one we can use in various places. And if we have a numerical pattern in the song, we could, like I said before, do something with a pattern of seeds. But yeah, all right, let's just go through now and just generate a bunch of 20-note random walks with no seed. So we get a bunch of unique ones. Now let's try to import one of these in. Let's see, what do I have? A strings. I could put this on the strings. We drag it in, and we see. Let's solo this. I don't know why. I guess snapping is not on right now. I want these to be faster. I don't know why these... Actually, should make sure it doesn't change. I actually want these to be eighth notes. I don't know why they're coming through as quarter notes. I guess that's kind of the way it happens. All right, well, let's try to make these all 127 just because. Put the seed back to 6. Make the duration, I guess if we make the tempo 4 times larger. I guess it always plays at the same tempo. All right, we just remade the seed 6 one. Yeah, now this is same thing. So we need to figure out why this is creating them with the same subdivisions. Tempo doesn't really matter in this MIDI file since we're just importing the note. I wonder if add note has any documentation. Track channel pitch time. I wonder if you can put a time signature. Nope, you can add a tempo. All right, so the way time works in this MIDI file thing is that it's always set to basically be in 4/4. So if you increment this by 1, every note is going to be a quarter note. You can increment by time plus I. You can divide that by 8, and then you can get a get eighth notes. Actually, no, I guess that wouldn't be eighth notes. Divide it by 2 and you'll get eighth notes because they're all quarter notes to start off with. And I think we want to divide by 4 to get 16th notes. So this was the one with the random seed of 6. Drag it into Reaper. The durations are much longer now. Let's make the durations shorter. Duration, we want to make this a quarter of a beat, so we have 16th notes. Let's put this on a different synth, actually. That's a little silly. That sounds kind of cool. That's weird, it's moving the volume things around. So I'm gonna have to find an instrument to jive with these notes, but we have a process for making them now. So that's that. Do this a whole bunch more times. So now all we really need to do is change the length in the seed, and we can play around with this. I think we should probably make them longer. Make them like, I don't know if we want to go to 30-second notes in this framework. We'll see. We'll just decide as we go here. But remake that one. Let's make one with no seed. Let's make a couple more. We can just keep running this. We'll just make. Save this notebook. And yeah, this is pretty much done for now. We can probably play with this a little bit more as time goes on. Wait a sec, what happened here? Oh, that's why. The tempo changes over here. I was wondering why it sounds so different. So yeah, they just kind of sound like random notes, which is exactly what they are. But, you know, that's it for now. Maybe we'll put them into a key later, and maybe we'll create a pattern of random seeds. But for now, we have the code in place. Maybe later we'll change this around if it doesn't sound good. But for now, I'm just going to kind of save it and work on something else. So, see ya.